Hello and welcome to this lesson on the surface area of pyramids and cones. As a quick refresher on pyramids, remember pyramids have some sort of like polygon base. So in this case, it's like a rectangle or a square. And then the lateral faces all come to meet at one point, which is how you differentiate between if something is a pyramid or a prism. There's a couple new terms we're going to be talking about in terms of pyramids. The first one is slant height, which is what we're interested in surface area. The slant height is the height of the lateral face of the triangle. So like if I were to take that triangle out, do you see how that's the height of that particular triangle there? In order to symbolize slant height, we use the letter L for lateral height, essentially. Now, I want to differentiate this between the height of the pyramid. Now, the height of the pyramid is actually used for volume. We'll talk about that a little bit later. But notice that it connects the vertex of the pyramid to the center of the polygon that's the base. So it's kind of cutting through that particular pyramid. Notice that the slant height and the height are different values. Which one do you think would be longer, the slant height or the height? Well, if you look at it this way, if I were to take that slice out, make this a right triangle, you see that the slant height is the hypotenuse of that triangle, and remember the hypotenuse is the longest side of a triangle. This distance down here, notice that this connects the center to the midpoint of one of those sides. We call that the apothem, assuming the base is regular, of course. The apothem. So the relationship between the apothem of the polygon, that's the base, the height, and the slant height, is that it forms a right triangle, meaning the apothem squared plus the height squared is equal to the slant height squared. We're not going to be working with this until the next lesson, so for now we can kind of ignore that. And let's just think about this in terms of surface area. If I want to find the surface area of a pyramid, I'm going to take the base area, which is down here, base area. Now, how many bases are on a pyramid? Just one. So that's what's different from prisms. You normally multiply it by 2. It's just the base area plus the lateral faces, which in this case would be all of the triangles. So if I'm looking at this first example here, and I want to find the surface area, I'm going to do the same thing we did for prisms, which is just to kind of cut it up into its pieces and add up all of the faces. So if I take out that yellow rectangle, which in this case it's a square because notice the dimensions are 6 by 6. I'm going to take out those dimensions, 6 by 6. I'm going to do 6 times 6 base times height for a rectangle. And that gives me 36 centimeters squared. Now looking at that pyramid, there's only one face of the pyramid that's that shape. So I'm not going to multiply by anything. I'm just going to leave it as 36. Moving on to those triangles. Now notice here that they give me the slant height. For surface area, that's really what you're interested in, is just figuring out that slant height and using that for the triangle. So if I were to redraw that triangle, I see that the base of that triangle is 6, and then the height, being the slant height, is 12. This is 6. This is 12. Remember, for a triangle, it's 1/2 base times height, so I'm going to do 1/2 times the base times the height. The area of one of those green triangles is going to be 36 centimeters squared. And then always check, well, how many faces on the pyramid are that have those dimensions and are that shape. So this triangle over here, notice that that's also 6 by 12. That's because the base is a square. So I'm going to take that answer and then multiply by 4, because there are 4 triangles like that on the figure. And that's going to be 144 centimeters squared. Once you get the lateral area, which is all those triangles, you need to add that to the base area. So my final surface area is going to be 36 plus 144. When you add those up, you're going to get 180. Make sure you include units for surface area. It's going to be centimeters squared. Moving on to our next one here. Why don't you go ahead and pause the video, try this one out by yourself, and then come on back when you're ready. Okay, folks, we're now going to go over this pentagonal pyramid here. First thing I'm probably going to do is actually the lateral area in this scenario, just because it's more manageable than that pentagon. I'm going to save the best for last. The base of that triangle is 16 millimeters, and then the slant height that they're giving me on the surface there is 20 millimeters. Remember that when you're finding the area of a triangle, you cannot forget to do that 1/2 base times height. Oftentimes people forget to do that 1/2. So I'm going to do 1/2 times the base is 16 times the height of that triangle is 20. 1/2 times 16 times 20 gives me 160 millimeters squared for the area of one of those triangles. Now remember to always go back to the pyramid and count, well, how many triangles are the same dimensions as the one that I just calculated. I mean, I should have told you that the pentagon was a regular pentagon. So I'm just going to take that 160 and multiply by the fact that there's 5 of those. And that's going to be 800 for my lateral area there, all those triangles, 800 millimeters squared. Make sure you don't forget to add that in at the end. I'm going to now move on to the pentagonal base, the pentagon at the bottom there. So right here, notice that that's 5 sides. If I redraw that carefully, we need to go through that whole process of finding the apothem, breaking up into triangles, etc., in order to find the area of this regular pentagon, which I know is everybody's favorite thing right now. So looking at the side length here, that's going to correspond to like one of the side lengths on the pentagon. The first thing we are going to do here, I like to divide it into my triangles. I'm going to do 360 divided by 5. That's going to give you that central angle measurement, which is 72 degrees. Remember that that represents one of the angles up here. When you draw in that apothem, that 72 is going to be bisected as well as that 16 side length. So what I think I'm going to do here is I'm going to take out this triangle here. I'm going to redraw it a little bit bigger for us so that we can see what we're working with. Notice, once again, I said that the 16 was bisected, so this is going to be an 8 now, an 8 millimeters. That 72 is also going to be cut in half. That's going to be 36 degrees. Remember that when we're finding the area of the triangle, we're interested in finding the height. Once I do that, I see that this is not a special right triangle, right? It's not 45 and it's not 30 or 60. So that means I'm going to be using SOHCAHTOA, sine, cosine, tangent. If you need to write that out, here that is for you. SOHCAHTOA. Once I do that, I'm situated at my angle here. This is the opposite. This is the adjacent. O and A means we're going to be using tangent. So I'm going to say tangent of the angle, 36 degrees, is equal to the opposite, 8, over the adjacent, which is the height. I'm going to put that over 1, and you can cross multiply. I know some people are more comfortable with substituting in, like, what's the tangent of 36 first and replacing that. That's fine. So that's going to be 0.7265 over 1 equals 8 over h. And then I'm going to cross multiply from there. So I'm going to get h times 0.7265 is equal to 8. Solving for h, you're going to divide 0.7265 on both sides. And then you get a height of 11-ish, 11.0111. That's a fun number. Once I get that height, remember you're not even close to being done. We're like a third of the way there, I guess, is one way to think about it. I'm going to find the area of the triangle at this point, of one of those triangles. So going back to my pentagon, my beautiful blue pentagon, I'm going to be looking at one of these big triangles. So if I were to redraw one of those big triangles, I see that the full base here is 16. So the full base is 16. The height we just calculated, that was 11.0111. I'm going to do 1/2 times the base is 16 times the height is 11.0111. Now that's the area of just the green triangle. Now, if I look back at my pentagon, how many green triangles are there? 1, 2, 3, 4, 5. So I'm going to make sure that I multiply my answer by 5. So times 5 times 16 times 1/2 gives me 440.44, around there, millimeters squared. Now that's just the area of the pentagon. Go back to your pyramid. How many pentagons are on that figure? Just one, right? It's not a prism. So what I'm going to do at this point is I'm going to add, for my surface area, that lateral area of 800 to my area of my base. So my final surface area, which is just gorgeous, 440.44 plus 800 gives me a final answer of 1,240.44 millimeters squared. Make sure you always include square units for surface area. Fabulous. We're going to move on to talking about cones at this point. So pyramids and cones are very similar in terms of the fact that they both have like one base and then lateral area that all reaches at one common point called the vertex of the cone or pyramid. Looking at this cone, remember it has a circular base. If I cut apart the cone, it's going to look something like this. You have the circular base, which corresponds to the bottom here, is that circle. And then, this is fun, when you cut up the lateral area of a cone, it actually looks like a hungry Pac-Man, is one way to think about it. So we know how to find the area of the circle, right? We know how to find the area of the base. It's not too bad. It's just pi r squared. So the first part for surface area of a cone is going to come from the fact that the base is pi r squared. So the base area plus the lateral area. Now, finding the area of the Pac-Man is a little bit more complex. We haven't learned about sectors yet in chapter 10. So for today, you're just going to have to take my word on like what the lateral area formula is for a cone. But if I look at this representation of it folded up, I know that this is the radius right here. The height, which corresponds to the height of a pyramid. Remember, that cuts through the middle and it forms that right angle. It's really obvious on a cone that the slant height, the height, and the radius all form that nice right triangle. So once again, we're not going to have to know this until the next lesson, but notice that the height squared plus the radius squared is actually going to equal the slant height squared, because notice that there's a gorgeous right triangle in here. But I'm getting ahead of myself. I'm getting too excited. I have pi r squared. Now, how do I find the area of the lateral space? Well, that's given by the formula pi times r times the slant height L. And once again, it has to do with circles and proportions, and it's really cool, and I'm excited to show you it later. But for now, just trust me, lateral area is given by pi times r times the slant height. So surface area of a cone, pi r squared plus pi r L. So if I'm looking at this first example here, I'm going to start by identifying the pieces that I have. I have that the radius is 1 meter, the slant height. Notice that they're not giving me the height in the middle, okay? They're giving me the slant height here, which is nice. Love those problems for surface area. It's not too bad. Notice also that the slant height is actually on the surface, right? You see it's on the outside versus the height is going to go through it, which we'll talk about that later. So I'm going to substitute into the formula surface area of a cone, pi r squared plus pi RL. So surface area is going to be pi times the radius is 1 squared plus pi times the radius times the slant height. Simplifying down, that's going to be 1 pi. Well, 1 times 3 is 3 pi. And then you can kind of add these, like imagine like if you're adding 1x plus 3x, you get like 4x. Same thing for these pi's, right? You have to add the numbers in front. So my surface area is going to be 4 pi. Make sure you pop on some units there. It's surface area, so it's going to be meters squared. That's in terms of pi. It's exact, you're not rounding. If you do want to round, just multiply 4 times pi is 12.57 approximately meters squared. Okay, so those would be your two answers. I just want to take a minute to talk about this next green cone. It's gorgeous. Before I let you try it on your own. As a note, if you see this drawn all the way through, implicitly it's actually talking about the diameter. I know it looks like it's pointing at like part of the diameter, but if they go through the effort of drawing in all the way across the circle, it's the diameter. So the diameter here is 8 yards, so the radius would be half of that, 4 yards. And then from there, I want you to go ahead and pause the video, try it by yourself, and then come on back. Okay, so finishing this last one up, I have my radius is 4 yards. Remember, for surface area, you want the slant height. So if I'm looking at this problem here, is 12 the slant height? Yes, it is, because it's on the surface, it's on the outside. The regular height would cut through it. We don't like that for surface area. So my slant height is 12 yards. From there, my surface area of my cone is going to be pi r squared plus pi rl. So my surface area is pi times my radius is 4 squared plus pi times my radius times my slant height. I'm going to simplify down. 4 squared is 16 pi. 4 times 12 is 48 pi. And then I'm going to add what's 48 plus 16. That gives me a beautiful 64. Don't drop the pi. Oh my gosh. Oftentimes students forget to write in that pi. They just write 64. You're adding those pi's together. So 64 pi yards squared is it in terms of pi. So that's exact. If I'm multiplying it through, depending on the problem, it'll tell you what to do. If they don't tell you, then you can choose. If I make it a decimal, it's approximately 201.06 yards squared. Once again, always make sure you have those units. That wraps up what we're going to be doing in terms of surface area of cones and pyramids for today. I hope you all have a great weekend, and I will see you next week.